In question 5a, long cables send electrical power from a supply point to a factory some distance away. An input power of 500 kilowatts at 25 kilovolts is supplied to the cables. In A part 1 we need to find the current in the cables. Well, current is power over voltage. Putting in the values gives a current of 20 amps. In part 2 we're told the resistance of the cables is 30 ohms. We need to find the power supplied to the factory by the cables. Well, the power lost in the cables due to resistance heating is given by this expression. Putting in the values gives 12,000 watts or 12 kilowatts. Therefore the factory gets the initial 500 kilowatts minus 12 kilowatts, which is 488 kilowatts. In part 3 we need to find the efficiency with which power is transmitted by the cables from the input at the supply point to the factory. Well, efficiency is power output divided by power input, which is 488 kilowatts over the input of 500 kilowatts, giving 0.976 or 98%. In B, we're given details of the electrical transmission system involving step-up and step-down transformers used in Great Britain. In part 1 we need to explain how a step-down transformer differs in construction from a step-up transformer. Well, a step-down transformer has fewer turns on the secondary coil than the primary, whereas a step-up transformer has more turns on the secondary coil than the primary. In part 2 we need to explain why the secondary windings of a step-down transformer should be made from thicker copper wire than the primary windings. Well, the secondary coil will carry a larger current, so needs a lower resistance to minimize energy losses through resistance heating. A thicker wire has a lower resistance. In C, we need to discuss the principles involved in high voltage transmission systems, explaining why AC is used in preference to DC and how energy losses are minimized. Well, the main source of energy loss in electrical transmission systems is heating of the wires due to resistance. The power of the heating of the wires is given by the expression current squared times resistance. So reducing the current is the most effective way of reducing these losses, as the current term is squared. As electrical power is equal to current times voltage, the same power can be transmitted using a high voltage and a low current, or a low voltage and a high current. By choosing the former, current is minimized, therefore resistance heating is minimized. High voltages require high levels of insulation and would be highly dangerous if sent into people's homes. Therefore, before reaching the end user, the voltage must be reduced and the current increases. Changing the current and the voltage is achieved using transformers, and transformers work with AC but do not work with DC. Some energy losses occur in the transformers, but by using laminated iron cores, these can be minimized.